Alright, so today we are going to be looking at the graphs of inverse trig. The three things that we talked about yesterday were inverse sine, inverse cosine, and inverse tangent. So those are the three that we're going to be talking about today. I have this little trifold note thing. So first let's talk about inverse sine. So we're just going to write out what we talked about yesterday. It is arc sine x or sine inverse x. Okay. The domain is from -1 to 1, and the range is from -pi/2 to pi/2. Okay, so again, that's review from yesterday. Then we're going to look at the graph. Okay, if we talk about what sine was to begin with, so this is the original sine, we went from -1 to 1, and we're going to cut off our bounds at pi/2. So this part of the graph is what it looked like. Okay, well the inverse is going to be the opposite of this. So on my x-axis I'm going to go 1 to -1 and -pi/2 to pi/2. Okay, so we're flipping our x and our y. So at -1 we're at -pi/2. At 1 we're at pi/2. Still kind of the same shape, but our x and our y has changed. Okay, and remember this one would keep going and so on and so forth. Okay, so then we're going to look at the transformation. So same thing from before, but now it's just with the inverse. So the A affects is a vertical stretch or shrink. So it affects what happens on the y-axis. The B is horizontal stretch or shrink. So it affects what's the x-axis. Okay, the C moves it left or right, and the D moves it up or down. So same thing as before. So if I look at y equals arc sine 1/3 x plus pi/2, I'm going to be using this graph right here to graph my new transformations. Okay, so this 1/3 affects my, I guess you could call it your period again, or your horizontal axis. Okay, we're dividing by the 1/3, so it gets 3 times bigger. So it goes from -3 to 3 now, instead of from -1 to 1. Okay, then we're shifting everything up pi/2. So up from pi/2 is pi. So we're taking this piece right here, shifting it up pi/2. So it's going to be on the x-axis. Okay, this piece where it normally crossed the origin is going to be at pi/2. And this piece that's up here at pi/2 is now going to be up at pi. So there's our new graph. Okay, so that was arc sine. So now we're going to go and we're going to look at inverse cosine. So we have, again, y equals arc cosine x, or y equals cosine inverse x. Remember, those are the same things, so we can interchange them. Our domain is from -1 to 1, and our range was from 0 to pi. Okay, so again, we could look at the original graph and just cut off the piece we're going to be using. So I'm going to go from -1 to 1 and from 0 to pi. Okay, so on this, everything is above our x-axis. So at 1, it was at pi. At 0, pi/2. And at -1, 0. So this graph looks like this. Okay, and again, we just switched our x and our y's to figure out this graph. Okay, so then for our example, y equals 2 arc cosine x. Okay, so this changes our height. So normally we went from 0 to pi. Okay, so now we need to figure out what we're going to be going from. So if we look at 0, so 0 to pi is our normal. Okay, now we're multiplying by 2. So I'm going to multiply both of these by 2. So now I know I'm going to go from 0 to 2 pi. Okay, so up here I'm going to have 2 pi, in between is pi, and I have 0, and still 1 and -1, because there's not a b, so that doesn't affect anything. Okay, so at -1 I'm going to be up here at 2 pi. At 0 I'm going to be at pi, and at 1 I'm going to be back at the origin. So there's our graph. We just shifted everything up by multiplying it by 2, because that's what affected our vertical stretch. Alright, last one is inverse tangent. So we have arctangent and tan inverse. Again, those are the same thing. The domain for this one is from -infinity to infinity, and the range is from -pi/2 to pi/2. If you remember, the asymptotes were at this, so that's why it's now our range, because it was flipped. Okay, so again, we're flipping x and y, so I'm going to have pi/2, -pi/2. And instead of having vertical asymptotes, I'm going to have horizontal asymptotes there. Okay, so the -1 and 1, again, at the original graph, it was at the origin. Okay, then we were somewhere about this way. Okay, so there is our inverse tangent graph. This is a graph we're going to base all of our transformations off of. So if we look at an example, y equals arctangent 2x. Okay, this affects my horizontal axis. Okay, it's a shrink. Okay, we're dividing these numbers by that. So they're now going to become 1/2 and -1/2. Okay, and then there's not a or a vertical thing, so my asymptotes are still going to be at pi/2 and -pi/2. So my graph's pretty much going to look the same, but now it's a little bit flatter. Okay, so there was that example. We have one more example of this, just because this one seems to be a little bit more complicated than the others. So I have 4/pi tan inverse of x minus 3. Okay, this affects on my vertical asymptote. So I'm going to take pi/2, which is what that is, and I'm going to multiply it by 4/pi. Okay, so when I do that, these pi's cancel, and this becomes 2. So now on my y-axis, I'm going to have 2, and if we do the same thing with this, it'll just be -2. Okay, so that lets me know where my new asymptotes are going to be. Okay, then this right here shifts everything to the right 3. Okay, so instead of starting at 0, I'm going to start at 3. So I'm going to go over to 3, start here. Okay, and then I know up from that. So there's my new graph. Alright, well, your assignment for this is A2, page 350, numbers 78, through 86 even. Let me know if you have any questions, and good luck.